So what we're going to do today is really go through a high-level overview of insulation. We're going to talk about what it is, what insulation does, how it works, talk a bit about the types of insulations, materials that are out there, specifically ones that Johns Manville makes. And then we'll also talk about insulation specifically for sound control and thermal control. And for the purposes of today's building, we're going to really focus mostly on commercial buildings. So first, what is insulation? And simply put, insulation is any material that we're going to use to control heat flow or to control sound. The reasons we're going to use insulation in buildings are to deliver thermal comfort and acoustical comfort, and also to reduce heating and cooling costs. And it's important to note that in commercial buildings, the building envelope can easily account for 25% of the total heating and cooling costs that we have. And finally, we're going to use insulation also to comply with codes and standards such as ASHRAE 90.1 or the International Energy Conservation Code. So to understand a little bit more how insulation works, it's first important to remember that heat always wants to flow from hot to cold. And in our buildings, what that means is that in the wintertime, of course, the heat wants to flow out of our buildings and into the outdoors. And in the summertime, hot air or just hot conditions outside want to come in and warm our buildings up. And heat is going to flow in and out of our building through several different modes. The first would be conduction, which is basically just heat flowing through mainly solid materials from hot to cold. Next would be convection, which would be heat flowing through fluids like air. The next one would be radiation, which actually doesn't require any sort of material, any solid or fluid at all, and radiation is basically how the sun heats up the earth. And finally is air leakage, which is really an exaggerated form of convection, but it's really important in our buildings because air leaking in and out of our buildings takes quite a bit of heat along with it that we then have to either add or remove with our heating and cooling system. And so insulation really works by slowing all of these heat transfer mechanisms in varying amounts. Many insulation materials also absorb sound, providing acoustical benefits, and we'll dig into that a little more later. So now that we've kind of talked a little bit about how insulation works, we need to understand how do we measure that. And when we talk about insulation, to be able to compare one material versus another, we want to use what's called R value. So R value was developed back in 1945 at Penn State University. And basically, all R value is a measure of resistance to heat flow. And R value gets determined from a test that we perform in the laboratory. So to measure R value, we take a sample of insulation and we place it in what's called a heat flow meter, kind of like the one shown in the photo at the bottom of the slide. And in the heat flow meter, we have a large plate, a cold plate, that we maintain at 50 degrees Fahrenheit. And then there's a hot plate on the other side maintained at 100 degrees Fahrenheit. The amount of energy then that it takes to maintain that temperature difference is carefully measured, and then we use that value to calculate the R value of the insulation. Because most insulation materials aren't completely solid, the R value actually does include all modes of heat transfer. So conduction, convection, and radiation, anything that might occur in the material is actually measured when we determine R value. And any R values that are published by insulation manufacturers are actually regulated by the Federal Trade Commission through what's called the R value rule. This rule was put in place actually back in the 1970s because the same insulation material can provide a different R value at different test temperatures and at different thicknesses. And so the R value rule was established to create a level playing field so that R value claims could be compared by people who weren't engineers or scientists. Finally, it's really important to note when we talk about R value that it was never developed or intended to account for things like air leakage or framing elements or complete building assemblies, right? It's really just meant to be a tool to compare materials. So now that we talked a little bit more about how insulation works, let's look at the different types of insulation materials that are out there. In the most broad sense, the two types of insulation materials that there are porous and non-porous. So porous materials are open structures that use fibers or foams to create tiny air spaces that provide the insulating effect. If we look on the slide, these top two photographs are from electron microscopes, and they show examples of fiberglass and open cell foam, how we can see that these tiny fibers and foam struts form little air spaces that help reduce conduction and convection, and then the struts themselves also scatter and absorb radiation. Porous materials tend to also provide good acoustical benefits. Non-porous materials are almost always foams, with the difference being that instead of air, the foams use other gases to provide an even better R value than what air can provide. And if you look at the third black and white photo on the slide, that's an example of polyiso foam, and you can see that in addition to the little struts, there are these windows of plastic that help hold in the gas. And so now that we've gone over kind of the main material types, we'll look a little more closely at several types of insulation that Johns Manville produces. So fiberglass is the first material we're going to talk about, and it's the most common form of insulation used in the U.S. today. Fiberglass can be made from raw materials such as sand, and it's also frequently includes recycled glass content. Fiberglass comes in many forms, such as rolls, boards, bats, and loose fill. And the density of fiberglass can range anywhere from under a half a pound per cubic foot to well over 3 pounds a cubic foot. Most fiberglass products provide thermal performance between R3 to 4 per inch of thickness. And because it's glass, fiberglass doesn't burn and does provide really excellent performance in fire applications, as well as good thermal and sound control. The main Johns Manville brands of fiberglass for commercial buildings are our formaldehyde-free thermal and acoustical insulation, and also our InsulShield line of products. So these products come in a wide variety of forms, and they're available both unfaced or with a variety of facing options. Mineral wool is similar to fiberglass, but instead of glass, the fibers are made from basalt, which is a type of volcanic rock. Mineral wool comes in bats or boards and in densities that range from 2.5 pounds up to 8 pounds a cubic foot. Mineral wool R values are similar to fiberglass, ranging from 3.7 to about 4.2 per inch of thickness, depending on the density. And one of the biggest benefits of using mineral wool is its fire resistance. Even though fiberglass doesn't burn, it does melt at a lower temperature than mineral wool, which melting temperature for mineral wool is above 2,000 degrees Fahrenheit. And this higher melting temperature means that mineral wool can stay in place longer during a fire, and that's why mineral wool is often specified for any sort of fire-rated wall or floor assembly. For commercial buildings, the JM brand of mineral wool is called just Min Wool, and we offer 3 product categories. Our sound attenuation fire bats are typically used in interior walls or party walls to improve both fire and acoustical performance. Our curtain wall products are used to insulate behind spandrel panels in curtain wall systems. And finally, our safing products are used to create a fire and smoke barrier in fire-rated floor assemblies, typically used between the edge of the floor slab and the back of a wall or curtain wall system. So next we're going to move on to talk about foams. And so in addition to fiberglass and mineral wool products, Johns Manville offers several types of foams. The first one we're going to talk about is polyiso cyanurate foam, which is often referred to as just polyiso. So polyiso is a closed cell foam, which brings with it a very good R value of about 6 per inch. JM makes polyiso into boards, which in addition to acting as thermal insulation, can also be used to create an air barrier and a water resistive barrier if the seams of the boards are taped and the penetrations are sealed. Polyiso boards can be used either above or below grade on the building envelope. So JM offers two brands of foam sheathing. The first is our AP foil faced foam sheathing, and the other one is called CI Max. Both of these products use a polyiso foam core. AP foil is often used on the exterior of buildings, kind of like what's shown in this top photo on the slide, and it can also be used below grade. AP foil can be used on the interior of a building, but if we do that, it's got to be covered with an approved thermal barrier to comply with fire safety code requirements. JM CI Max foam sheathing has actually been tested and specifically approved so that we can leave it exposed on the interior of buildings without a thermal barrier. So CI Max comes, because of that, CI Max comes with a plain white or silver side that doesn't have any printing to provide a clean, visible surface. And the lower right photo shows an example of CI Max installed, some white CI Max on the interior of a large building. The other type of foam that's offered by Johns Manville is spray polyurethane foam. JM offers two types of spray foam, open cell and closed cell. So open cell foam uses either water or carbon dioxide as the blowing agent, and during the foam installation, the foam bubbles actually pop, leaving behind an open structure of plastic struts, like what we saw in the earlier slide under the microscope. So even though these cells are open, they are pretty tiny and small enough that open cell foam does provide an air sealing benefit if we install it at least 3.5 inches thick. Closed cell foam, though, uses a chemical blowing agent to create a network of tiny sealed bubbles similar to polyiso foam. And the gas inside the bubbles insulates better than just air, which is one reason why closed cell foams have a higher R value. Closed cell spray foams also do provide an air sealing benefit, but at much less thickness, only 1 inch thick for our closed cell foam products. Because the cells are closed cell foam also provides a water vapor retarder benefit and is approved by the building code as a vapor retarder. So the Johns Manville spray foams are all branded under our Corbond name. Our open cell products are called Corbond OC-SPF and OC-X SPF. And these materials deliver R values of 3.8 to 3.7 per inch. Specifically, our OC-X product satisfies the testing requirements from NFPA 286 Appendix X, so that this material, if it's used in attics or crawl spaces, does not require an additional ignition barrier over it to meet fire code. Our closed cell products are called Corbond MCS and Corbond 3. Corbond MCS is our multi-climate solution, which delivers an R value of about 6.3 per inch. And Corbond 3 is JM's premium spray foam product, delivering a superior R value of R7 per inch. And our Corbond 3 provides good yield in many different climates and temperature conditions. So now that we've talked about different insulation types, let's talk a little bit about where we're going to find insulation in commercial buildings. So for commercial buildings, we're going to find insulation used in a bunch of different areas. In the exterior envelope, insulation is going to be used in the roof, the walls, and curtain wall systems, below grade walls, even below the slab to help reduce heat flow in and out of our building. And on the interior of the building, insulation is going to be found inside interior walls for sound and fire control and as part of acoustical finishes. We're also going to find insulation in heating and cooling equipment, on heating and cooling ducts, and on water or steam pipes. So next we're going to dig into some of these applications in a little more detail. So one of the main places that insulation is used is in framing cavities that are formed by walls and roofs and floors. So typically, we want insulation to fill these spaces completely to reduce the chance for heat or sound to find a path around the insulation. The table on the slide highlights some of the more common framing sizes in commercial construction and the corresponding fiberglass and mineral wool products that we would use in these applications. So for example, walls framed with 2x4 wood studs or 3.5 or 3 5/8 inch steel studs could take fiberglass anywhere from R11 to R15. 3.5-inch sound attenuating fire bats for mineral wool or R15 temp control mineral wool would also fit in these applications. 4-inch steel studs would then require 4-inch SAFB mineral wool bats. In 2x6 wood studs or 5.5 or 6-inch steel studs, we would use either R19 to R21 fiberglass or R23 temp control mineral wool. All of these framing applications could also take either open cell or closed cell spray foam. Additional applications for fiberglass specifically could be above acoustical ceilings, which we'll talk about a bit more shortly. And Johns Manville's encapsulated Comfort Therm product works really well in this application. Because our Insul Shield products come in such a wide variety of forms, this product can be found almost anywhere in a commercial building, from wall cavities to curtain walls, on mechanical equipment, or even as part of a sound-absorbing room finish. So for buildings, insulation is often needed beyond just in the framing cavities. In many wall systems, the wall framing can account easily for 25% or more of the total wall area. And heat would much rather flow through this framing and around the insulation, and this effect is called thermal bridging. So the infrared image at the top of the slide shows this effect in a wood-framed wall, where we can see the framing highlighted as pink warm spots showing through the wall system. And this effect is called ghosting, and it's even worse in a steel-framed wall like the photo in the center at the bottom of the slide. Continuous insulation, or CI for short, is used to reduce this effect. JM products that can be used as continuous insulation include our AP foil and CI Max foam sheathings, and also our closed cell spray foams, Corbon 3 and Corbon MCS. And the photo at the bottom right of the slide shows an example of our AP foil foam sheathing used as exterior continuous insulation. When it's used as CI, specifically spray foam, is also usually applied to the outside of a building. And when it's used this way, closed cell spray foam provides continuous insulation as well as air sealing and water protection in one step. So we've mentioned a couple times about how insulation is often used for sound control, and on this slide we'll dig into that a little bit more. Most of the time we use insulation in walls to improve what's called the sound transmission class, or the STC rating of a wall. STC is a rating applied to the whole system to describe how much sound is stopped by the wall going from one room to the next. STC is usually measured in the lab, but it can also be measured in the field by an acoustical consultant. So STC ratings are really important because this measures how well the wall is going to deliver privacy between spaces like offices, hotel rooms, or apartments, and also for creating quiet environments in schools and hospitals. It's really important to point out that STC ratings only apply to the entire system, whether that's a wall or a floor ceiling, not to individual products. We should really never see STC ratings advertised or published for just a piece of insulation or a piece of drywall, for example. The table on the slide shows some examples of STC ratings for various types of steel-framed walls that we might see in commercial buildings. So the STC rating range in each row includes a lower value that would be without insulation in the system, and higher values that would include insulation in between the framing. As we move down the table, we are adding either more layers of gypsum board or more layers of framing or resilient channels to get higher STC ratings. In general, when we add porous insulation to a wall, we're going to increase its STC rating by about +5. And again, it's important to reinforce here that porous insulation materials make for better sound control. So fiberglass, mineral wool, open cell spray foam are going to provide better sound control performance than any sort of closed cell foam. So another common application for sound control insulation use in commercial buildings is going to be over dropped or acoustical ceilings. So in many commercial buildings, right, we have dropped or acoustical ceilings used with an open plenum space above for utilities and mechanical equipment. And oftentimes interior walls will only extend to the ceiling rather than on up to the floor deck above. And if you see the drawing on the slide really kind of shows this, where the wall stops short of going up to the structural floor deck. And what happens then in this case is that this allows what we call flanking noise can move around that wall, reducing the STC rating it's going to be able to deliver and also reducing the privacy that the wall was intended to provide. However, if we add a layer of fiberglass batts on top of the acoustical ceiling tiles, this has been shown to greatly improve the overall performance of the system. What we're doing here is that the sound absorption that the fiberglass adds to the plenum space immediately above this wall reduces that reflected noise that would otherwise bounce over and then go back down through the ceiling into the next room. In this sort of application, batts should be laid so that they extend across the wall, and they should be kind of butted up tightly side by side to each other. Typically R13 or R19 batts tend to be used. Johns Manville's unfaced fiberglass batts and our encapsulated Comfort Therm products work really well in this application. So to summarize, where we're going to be finding insulation used in commercial building insulation, we've got this good drawing with some cutaways on it. And so for exterior walls, right, we're going to find insulation in between wall framing, typically either fiberglass, mineral wool, or spray foam. Excuse me. In curtain wall systems, we're going to find mineral wool used behind the spandrel panels. For continuous insulation on exterior walls, we're going to see either polyiso foam sheathing or closed-cell spray foam. And then finally, on the interior of commercial buildings, we're going to find insulation, both fiberglass and mineral fiber, typically used in interior walls for sound and fire control, and also in mid-floors, interior floor ceiling systems for sound and fire control. So now we're going to move on a little bit to energy code and why insulation is going to be used in our buildings. Right, even though comfort and energy saving should really be all the reasons we need to put insulation in buildings, the main reason still does tend to be energy code compliance. The two main codes in the United States are the International Energy Conservation Code, or IECC, and ASHRAE Standard 90.1. The IECC is usually what is actually adopted by jurisdictions such as states, counties, or cities, but the IECC does include a reference to 90.1 as an equivalent compliance path. Most commercial buildings in the U.S. are actually built to the ASHRAE 90.1 standard, whereas residential buildings tend to be built complying with the residential portions of the IECC code. In general, states are not obligated to adopt or enforce any version of the energy code, which does actually get updated every 3 years. The map on the slide, though, shows the most recent view of code adoption across the United States, focusing here on the ASHRAE 90.1 code, seeing as we're talking about commercial buildings. As we can see, code adoption, right, varies widely from states adopting the most recent version of the codes to many states not adopting a statewide code at all. In the states that don't adopt a statewide code, then the individual jurisdictions, like cities or counties, would be the bodies to adopt and enforce a given version of the code. But even in states that do adopt a statewide code, those individual jurisdictions could adopt a more stringent version. So it's really important to always check with your local building department, because those departments are going to be the ones that actually enforce the code, and they're always going to be able to tell you what version of the code a given project is going to fall under. Broadly speaking, the energy code is going to specify a broad range of requirements. Insulation will be one of those that we'll talk about in a little bit more. And because code adoption at the state level and local level varies so drastically by geography, what you're going to find is that the product offerings at various Johns Manville plants will vary as well, so that we can try to match up what we stock in the plants to the needs of the local market. So one of the key features of the energy code and insulation requirements is what's called climate zones. And so the map on this slide shows the climate zones that are defined and used by both the ASHRAE and the IECC energy codes. And in the simplest form, the higher the climate zone number, the colder the climate. But notice that climate zones are defined across the country by county, not by state. So many states could have multiple climate zones, and so it's important to know not only what code your project is under, but what climate zone it's going to be in. And if we move on into the energy code a little bit more, we'll see on this slide an example of insulation requirements for the building envelope from the ASHRAE 90.1 standard. So the table shows insulation requirements in terms of R value for many different building elements by climate zone. So building elements are listed across the top, and most of those, such as metal framed walls, wood framed walls, are pretty self-explanatory. But a couple that might need a little bit more explanation would be things like mass walls or mass floors. So anything like that is really describing a concrete or block or any other sort of solid and heavy construction. The column labeled roof above deck is referring to low slope roofs where the insulation should all be on top of the roof deck. There are other requirements for attics, but we didn't include those given that that tends to be more residential or multifamily applications. And we're focusing on commercial buildings today. As we look down, right, we've got the different climate zones by number. For the insulation R value requirements themselves, just a single number by itself represents the minimum R value of the cavity insulation. So that would be, right, insulation that's going to fit in between the framing in a wall or a floor or a roof. Any number with a CI after it is going to be representing continuous insulation, which we talked about earlier would be usually foam sheathing. It could also be exterior spray foam, right? But this is insulation that's got to be installed continuous across the framing elements. But that continuous insulation could be interior or exterior, especially in walls. So notice, right, the general trend is that the higher the climate zone number or the colder the climate, the higher the required R value and the amounts of insulation that are going to be called for in all parts of the building. Notice also that the R values in the energy code table don't always exactly match with R values that are offered by manufacturers. And finally, it's worth pointing out that the insulation requirements on this table are only one way to comply with the building code. So these are prescriptive values from the building code. There are a lot of other performance and trade-off options that the building code offers that will let you potentially change what these numbers are, or how much insulation is put in a given area of the building. So to wrap up, or to start to wrap up, let's first summarize and compare some of the different insulation products that Johns Manville makes that we've talked about today. So the table on the slide is fairly full, but it's really just meant to summarize different product types, showing their different thicknesses, their different thermal performance or R values, and then how they tend to perform in things like fire or for air sealing and moisture control. So first, remember, fiberglass and mineral fiber bats and rolls are going to be primarily used in wall or floor framing cavities, and we're going to use those for thermal and sound control. Product thicknesses for fiberglass and mineral wool vary broadly from 1 inch thick Insul Shield or mineral wool up to 13-inch thick fiberglass bats. And likewise, R values have a really wide range. But again, these products typically have thermal performance in the range of between 3.5 to R4 per inch or so. Fiberglass packaging in particular uses a color coding system which makes the R values more easy to identify. Both fiberglass and mineral wool perform well in fire testing, with most materials classified as either Class A or non-combustible. It's important to remember that fiberglass and mineral wool do need to be paired with some kind of air barrier or air sealing when they're used in the building envelope. and that fiberglass and mineral wool by themselves don't stop water vapor movement and are not considered vapor retarders by the building code, but faced products can provide vapor retarder functions. JM spray foam comes in both open and closed cell formulas, right? So spray foams typically installed in framing cavities, but again, closed cell products can also be used on the exterior of the building as continuous insulation. Thermal performance, right, of open cell foams is about 3.8 per inch or so, and 6.5 to 7 per inch for closed cell products. Remember that all spray foams have to be separated from the occupied space by a thermal barrier such as gypsum board, but that our Johns Manville's OCX spray foam is allowed to be left exposed in crawl space and attic applications in certain conditions. All spray foams will provide an air seal function if installed to their minimum thicknesses, so that would be 3.5 inches for open cell and at least 1 inch thick for any closed cell spray foam. And closed cell foams do also provide vapor retarder functions that might be called for by the building code. But open cell foams are vapor open and don't provide any vapor retarder. Finally, JM's polyiso foam sheathing products are really intended for use as continuous insulation. Foam sheathing is available in a wide variety of thicknesses and R values from R2.7 up to R28. Our AP foil faced foam sheathing, kind of like spray foam, must be separated right from the occupied space, but our CI Max product can be left exposed, which can be really useful for interior applications. And remember that all foam sheathing products can also be excellent water barriers and vapor barriers if we tape all of the board seams and seal up any penetrations. And your Johns Manville rep can provide you recommendations for tapes that work well with our foam sheathings. So to wrap up, Johns Manville, just to kind of reinforce this a little bit, Johns Manville really does have the most comprehensive insulation product portfolio in the industry with fiberglass, mineral fiber, spray foam, and board foam products. And in addition to that broad portfolio, we've invested heavily in stocking our products in all of our building insulation plants so that our customers can mix loads and get multiple products delivered in one truck to match their project or market needs. So finally, in summary, let's go back over some of the main points that we've covered about insulation in general, right? So we're going to use insulation in our buildings to deliver thermal and acoustical comfort, to reduce energy costs, and to help us comply with building energy codes. Insulation works by slowing heat flow, by reducing conduction, stopping convection, and blocking and scattering radiation. And R value is really the primary way to compare the performance of different insulation products. Insulation does come in two main types: porous materials such as fiberglass or mineral wool, and non-porous such as spray foams or board foams. And as we saw on the earlier slides, every material kind of has its strengths and weaknesses, and there's really no single product as a substitute for good building design. And finally, we'd like you to remember that JM wants to be your source for the most complete line of building insulation products and expertise. And with that, ladies and gentlemen, thank you. We've kind of concluded the seminar part of our session today. My colleague Gina Carosa is here, has been seeing the questions come in, and she's going to help read through those, and we will get you answers to those. Gina?
Thank you, JR. We've had a few questions come in, and to start, are there any concerns in utilizing AP foil on a concrete block wall, given the fact that the foil acts as a vapor retarder?
No. I would say the short answer is no, there's not. A block wall, for one, block walls don't care so much if they have a little bit of moisture in them. They have quite a capacity to hold water vapor. And so if the AP foil was used also as the drainage plane and the air barrier, very little water should get behind that, and any that did could then kind of work its way into the building. You know, it could dry into the building then from there. So no, there's no real concern with putting that on a block wall. In a cold climate, we might specify a minimum thickness to help deal with condensation control.
Okay, thank you. Is AP foil an alternative for XPS on below grade applications?
Yes. So historically, there have been many various papers and pieces claiming that polyiso shouldn't be used below grade. And I know here at Johns Manville, we've been working pretty hard over the last 10 years or so to try to refute a lot of that. And what we have found is that polyiso can work in below grade applications every bit as well as XPS can. We haven't seen any examples where it shouldn't be used that way.
Okay, thank you. Are there differences in codes between commercial and residential buildings?
It's a good question. So there are. The IECC has a whole residential section that calls out specific insulation requirements for residential buildings versus commercial. And in general, the insulation requirements tend to be a little bit higher. But so there is a difference, and that's kind of why we focused more just on one side of that market today, I think.
Okay. Does mineral wool have an R value?
So mineral wool does have an R value, even though we often use it for sound and fire control. Mineral wool R value, and actually we can jump back up to that because we have that on the slide. Right, mineral wool R value tends to range between 3.7 to R 4.2 per inch. So very comparable, sometimes even a little bit higher than what we get out of fiberglass.
Thank you. What is the good, better, and best products for sound control?
So for sound control, kind of as we touched on that just briefly earlier in the talk, but porous insulations like fiberglass, mineral fiber, and open cell foam are really what we want to use for sound control. We want materials that will absorb sound well. Closed cell foams, as their name implies, are pretty closed off, so they don't absorb sound, and they tend to be a little too rigid for good use in noise control applications.
Okay. And it looks like one of our last questions, does JM sell the fasteners and tapes for foam sheathing?
So for foam sheathing, Johns Manville does sell the fasteners. We do not directly sell the tapes, but we have evaluated a lot of tapes and can provide recommendations of tapes that work well. And so if you contact your JM rep, whether it's for AP foil or for CI Max, they can give you the recommendations on those materials and kind of where to find them.
Looks like we had another one come through. Thank you on that.
Okay.
It looks like we're on the same theme, but on the foil sheathings, do you need to tape the joints if you have a vapor barrier behind it, such as grade D building paper or Tyvek?
So that's a great question, and the answer is no. So though we highlighted that you can tape the seams on foam sheathing and then use it as your drainage and air barrier, you don't have to. And putting something like grade D paper or a house wrap behind foam sheathing like AP foil can actually work very well. And in that case, it's best to just leave those seams untaped. That way any water that might want to get back behind there and encounter that house wrap can still then drain out at the bottom of the wall.
That concludes our questions. You will receive a survey following the webinar, and we would appreciate it if you would take a little time to offer your feedback on the webinar today. Additionally, again, if you have questions that you were unable to ask, you can submit them via the survey and we will respond to you directly via email. We thank you all for attending today and hope you enjoy the rest of your week. Thank you, JR, as well.
Thank you, Gina. Thanks, everybody.